Hello friends, welcome to our YouTube channel Electronics for You. Our topic is active elements. So active elements are basically the energy sources which are capable of delivering power to some external devices. But friends, some external devices, for example capacitor and inductor can also provide power. But the average power of these devices are not zero. Therefore, in more specifically we can define active elements is capable of delivering average power greater than 0 to device over infinite time interval. Now the examples of active elements are voltage sources and current sources. So simply we can say that energy sources are the active elements. Here, according to their terminal voltage and current characteristics, they are categorized into ideal voltage source and ideal current source. Further, again they are classified as independent and dependent sources. So first the ideal voltage source, depending on the terminal voltage, if it is providing a constant voltage, then it is called as ideal voltage source. But specifically, if we want to define the ideal voltage source, these are the voltage sources whose value of voltage is not dependent on the current. It means that for any value of current, it will provide you the constant voltage. But constant voltage doesn't mean that it always provides the DC voltage. For the AC voltage also, here the graph will be the changing of voltage, but for any value of current, it will provide you the voltage in that particular range. But if the current is infinite, again the voltage characteristics will not change. So practically, if we are applying some voltage to this is the symbol for the ideal voltage source. Here you can see this plus and minus sign along with the battery. Now if we connect some resistance here, then definitely the current will start flowing through this resistance. Now let that current be the IT. This current will depend on the value of this resistance. If this resistance is very high, definitely the current is low. But if the resistance is very low, the current will get increase. And as the value of this current will increase, still in ideal voltage source it will provide you constant output. It means that you will get here if the terminal voltage is Vt, then you will always get it is equals to Vs. Means a 5 volt ideal voltage source will always provide you the voltage supply of 5 volt. But practically, ideal voltage sources do not exist. Therefore, we can say that in practical voltage sources, the internal resistance is in series with the source. Here you can see that the resistance is in series with this ideal voltage source. So in practical voltage source, the resistance is in series with the voltage source. And here the characteristics of practical voltage source, as the value of I is increasing here, the output voltage falls. It means that in practical voltage source, the output voltage is dependent on the current. The terminal voltage Vt is equal to Vs minus Is into R. How it is calculated? Let us again apply the KVL to this loop. Okay, so here it is say the current is flowing like this, so it's positive terminal, it's negative terminal. If we move like this, and if it is the terminal voltage Vt, then you will get, let us move from this point. So here Vs minus Rs into the current flowing, let it be I or IT, then this is minus Vt equal to 0. If we bring Vt on the second side, you will get it is Vs minus Is into R. This is the same formula that we are getting here. Okay, so for Vs equals to 50 volt and R equal to 10 ohm, if Is is 1 ampere, what is the terminal voltage? If we put the value, then we will get terminal voltage equal to 40 volt. But if we increase this quantity of Is to 2 ampere, then the Vt is equals to 30 volt. It means that as the value of Is is increasing, the voltage is decreasing. Here you can see this. So along with this Is, if this R also increases, then also the terminal voltage falls. It means that for the practical voltage sources, this resistance should be very small, so as to bring them equal to ideal voltage source. The examples of ideal voltage sources are battery and alternators. The next point is ideal current source. Here you can see this is the symbol for the ideal current source. Here the arrow is inside this circle. The arrow indicates the direction of current. In ideal current sources, definitely it provides the constant current for any value of voltage. But in practice also, ideal current sources does not exist. Therefore, the practical current sources are there. So in practical current sources, the internal resistance is in parallel with the source. Here you can see this resistance is in parallel with this. And again, if the terminal current is IT, and here we should get the constant output. But for practical current sources, as I have already mentioned that the voltage will as this terminal voltage increases, the current will fall because of this resistance. So the terminal current IT is equals to Is minus Vs upon R. Here Vs is the source voltage that should be there. Resistance is the parallel resistance, which should be very high, so as to bring it near to the ideal. Okay, so the current always takes the path of least resistance. So in order for the current to go to the path of least resistance, we must connect the resistance higher than the load, and this should be very high for constant current. But ideally it should be infinite. Infinite means this should be open circuit. And the examples of current sources are solar cells and transistors.